All right, picking up where we left off with, we were talking about body waves and the waves that are produced during an earthquake. P wave was the first one we started with, moves by compression. We said moving kind of back and forth, like a compression and refraction. Where S waves are called secondary waves. They're transverse. They're going to move up and down, much more like an ocean wave. Because the direction of movement is actually 90 degrees from where it was. So it goes across, it's going to move at 90 degrees. Because it's got to move more matter up and down, it can only travel through solids. It can't travel through liquids or gases. And because they are moving more material up and down, we end up finding that they are slower than the P waves. So as you see, here's the direction of movement of that wave. If we were going left to right, notice it's got to move it up and down, which is 90 degrees to that. And that makes more material to move up and down than just compressing it and refracting it. The third is the L wave, which we call the land wave, but it's not a body wave. It doesn't go through the interior. It only occurs at the surface. Because it occurs at the surface, it's the most destructive wave. And it is at the surface moving material up and down, and it ends up moving the slowest. So if we were to look at just a common seismograph, you get a small bit of movement of the ground during the P wave. It's more, like I said, just a pulse that's going to tell you that the earthquake is coming. And then we would get a larger movement, some lag time in between there, which is going to help us figure out how far away the epicenter was. And the S wave will move up and down. And then the largest movement is the surface wave. So this would be a seismogram that would show us that an earthquake has taken place. P waves, again, travel through solids, liquids, gases. S waves only travel through solids. And surface waves are only at the surface, and they're going to be the ones that cause the most damage when we talk about that. In order to figure out where the epicenter actually took place, you have to take 3 seismograph stations, because all that it does, that lag time between the P and the S wave that we just looked at, this lag time, the amount of distance in between these two things means that it's farther away from the epicenter. If these two are very close together, then obviously your location, or the seismograph's location, is closer to the epicenter. That lag time is what's going to help us to figure out, because they're all produced at the same time. But when one moves faster, the farther away you are, you're going to get that faster wave to hit you first, and then the slower wave to hit you second. So all it does is tell us the distance you are away from the earthquake or the epicenter. It doesn't tell us in what direction. So what you end up doing is making a circle. And when you point all 3 circles together, where they all intersect is where the epicenter would be. Now, you could do 4 or 5 other seismographs to figure it out, but you need at least 3 to be able to figure it out and to pinpoint. Because if I only use 2, say this yellow one and the blue one, it could either be where we mark the epicenter, or it could have been over at this marking. 2 circles will connect at 2 different points. 3 of them will only produce 1 point or 1 epicenter. Here's just a graph showing that S wave, and what we're trying to find, the distance away from it, the larger the distance between the S and the P wave. We look at how do we measure earthquakes. Earthquakes measured in 2 different ways. There's one way is to measure its intensity, and the intensity is going to be the amount of damage that takes place. This is called the Mercalli intensity scale, or just the Mercalli scale. It's usually designated as a number 1 through 12 in Roman numerals, and it is based on how much damage there was. So you'd have to go around, or geologists would have to go around and survey the area to figure out how much damage was done. And you would come up with a scale, say this one was a 2, that one was a 4. Usually the epicenter would have the most damage, and that's where you could pinpoint that. But magnitude is a little bit different.